All right. This is Mr. Longo here. Going to show you how to prove triangles congruent by a series of rigid motions. So, little disclaimer before I do this example and before I do the next example for you, after you had the opportunity to give it a try, there are many different ways to do these questions. So, there are correct ways and wrong ways, but there are many different ways to do it correctly. Okay? So just wanted to give you that little blanket statement before we started. All right. So what we're going to do here is we're going to prove that triangle ABC is congruent to triangle A prime, B prime, C prime using transformations to map the blue ABC to the purple A prime, B prime, C prime. And you can go both ways, but I just want to make sure that we're on the same page here for this first example. The next one will be up to you. So theoretically, there's many different ways you can do this. But since we are confined to a grid where we go from -10 to 10 in both the x and y direction, a lot of times it's helpful to try to keep whatever figure you're moving on the grid. So that'll limit you a little bit. So first thing you want to do is you want to look at some ways where you can match up A with A prime, B with B prime, or C with C prime. And that means right off the bat, you have 3 different choices to start this problem out. Now, you probably wouldn't want to move A to A prime because then, like I said, your triangle is going to be below the grid and you're not going to have good grid points. So that might not be your first option. But as you can see, it's pretty easy to get B to go to B prime and C to go to C prime. So really, you just want to pick one of those. I'm going to choose C to C prime. So if you look, C to C prime, it's on the same Y level. We just need to switch it over to the right. So in order to do that, we would have to translate 7 units to the right, and then C will be sitting right on top of C prime. So step 1, we're going to translate 7 to the right. In coordinate notation, that would be x plus 7, comma y. So that's what we're going to do, and you actually want to draw it. So we're just going to move that 7 to the right, move this guy 7 to the right, and this guy 7 to the right. Okay, so that's the first step. Now, we see that we could map A and B with a reflection. So you have to be very specific of what type of reflection you want. In this case, we're just going to reflect over y equals -1. That's our horizontal line right here, this green line. So that means C is already where it needs to be. This coordinate A is 8 units above the line, so now we have to go 8 units below the line, and we just mapped A to A prime. And then this point is 2 above our reflection line, so we now move it 2 below our reflection line. And with 2 rigid motions, or 2 translations, we just mapped A to A prime, B to B prime, and C to C prime. And that's it. You're done. That's how you prove it with rigid motions. And like I said, there's many different ways we could have done that. We could have mapped B to B prime first and then reflected over y equals a -3. You could have reflected first and then translated. There's all sorts of different ways you can do this. Just make sure you understand that. Okay? So that's it for my example of the notes. If you would like to try one of your own, here you go. Feel free to take a minute to do this. Again, there are many different ways you can do it, and I'm not even going to tell you which way you want to go. You might want to move DEF to ABC, or you can use ABC to DEF. If you move ABC to DEF, I will tell you you have a little bit more limitations than if you were to go the other way, but You do it any way you want. As soon as you're ready to see how I'm going to attack it, you go right ahead and press play. Give it a try. So let's see if you got it correct. Now again, I will understand just by reading through your own steps if you did it correctly or not. Again, this is just an option. Like I said, for this one, it probably was a little bit easier to move triangle DEF to map to triangle ABC. Reason why? If you decided to translate this first, if you would have moved A to D, this one would be off the grid. If you were to move B to E, C would still be off the grid. The only way if you wanted to move using a translation first to do this would have been to move C to F and then do a counterclockwise or a clockwise 90 degrees rotation, and then you would have had it. But if you wanted to do triangle DEF to ABC, you would have had more options. So that's what I'm going to do to start. We know that A has to match up with D. We know B matches up with E and C matches up with F. So the first thing I'm going to do is I'm going to map E to B. So to do that, I'm going to first translate XY to X minus 4, comma Y. That will put E on top of B. So that's going to give us E. And then that's going to move this guy 4 points to the left as well. Here's our D again. And move this guy 4 points to the left. That's going to give us our F. So here's our first step. Now we can see this is not a reflection vertically or horizontally, but what we need to do for this one is rotate about point B 90 degrees counterclockwise. So if we rotate this 90 degrees counterclockwise, we should have our solution. So let's check it out. Step 2, rotate counterclockwise 90 degrees about point. That would be our E. So now E, instead of going to D right 5, we're going to rotate counterclockwise and move it up 5. And then instead of F being to the right 5 and down 8, we're now going to go up 5 and right 8. And we just mapped ABC to DEF. And there we go. So again, 2 transformations to prove that triangle ABC was congruent to triangle DEF. So again, you could have done yours many different ways. I just wanted you to see another example of how it can be done. This is Longo, and I'm out. See you, bye.